All right, in the last video, I made a quick comment about finding the turning point of an equation. In this case, it's a quadratic, and if we expand this out, we get x times x is x squared, 3 times negative 2 is negative 6, and 3x and minus 2x is just plus x. So there's the equation. And if we look at this from the perspective of the general equation of a quadratic, it's y is equal to ax squared plus bx plus c. Now, when we looked at the turning point, we actually have a little expression for turning point, or you could say the x value of the turning point is minus b over 2a. Now, this is quite a useful thing to know if you can just look at the equation here and work out exactly where the turning point of this graph is going to be. It's a useful thing to be able to do. So if we look at the turning point, where is it? It's going to be, well, if I draw this out, I'm going to have this crosses at negative 3. It's plus 3 there, so it's going to cross at negative 3. It's negative 2 here, so it's going to cross at plus 2 here. 3 times negative 2 is negative 6, so it's going to cross at negative 6 down here. And the graph is going to look something like, and I'll try and draw it as best I can. This is not going to be perfect, but hopefully it will be good enough to explain what we're doing. And it's not perfect. But we can see this crosses at negative 6 here. This crosses at positive 2 here, negative 3 over here. And we can see that it goes down a little bit below 6. In fact, it goes down to this point here. Now, we can't see exactly what that point is because it doesn't coincide with any particular intersection of lines on the grid. We also can't see exactly where it is here, but it has got to be halfway between these two. And we know that we've got a negative 3 and a 2, and the distance there is 5, and half of 5 is 2.5. So if I go 2.5 in this direction, 1, 2.5, or 1, 2.5, I'm going to arrive at this point here. So we can just say 2 minus 2.5 is negative 1/2, or negative 3 plus 2.5 is going to be negative 1/2. You could do it either way, it doesn't really matter. But the fact is that a parabola is symmetrical around its mirror line, which would be the halfway line. Question of those, how can you just find that using this nice little expression here? And of course, we can just then put in, we can say, well, what's the a value here? Here the a value is 1, it's the coefficient of x. Coefficient of x here is going to be a 1, and the coefficient of this one here, x to the 0, is going to be a negative 6. Now, we know that from the last video. I went through that, and that's all cool. But where does this come from? What's the deal with this thing? Well, this is actually something which we can show with calculus. So let's have a look at using calculus to actually find this thing here. Well, we know we've got a general equation for a quadratic, which is y equals ax squared plus bx plus c. Now, if we were to say we want the gradient, leaping ahead of myself. If we want the turning point, we notice at the turning point, the gradient is actually 0. The gradient here is 0. Here it's going to be like 1. Here it's going to be like 2. The gradient's going to be like 3 or 4 or 5 here, and so on. And the gradient's going to get steeper and steeper. Same on the other side as well. The gradient's going to be a bit steeper here, a bit steeper over here, and so on. So if you were to look at what the gradient was at different points, you could find it, but the gradient right at the turning point is 0. It's just a horizontal line. It's this flat, level line. So the m value, or the gradient at that point, is 0. So if we were to find the gradient function for this equation, and we were to make the gradient function equal to 0, we could find the function, or rather the expression, that describes how to get to the turning point. So let's have a look at doing that. So if we were to differentiate this, and let's have a look, so we've got dy dx, we're differentiating y, which is all of this, with respect to x. So we're going to multiply the coefficient by the power, that's going to be 2 times a, and reduce the power by 1, it's 2x squared becomes 2x to the 1. We've got a plus bx here, and we're going to multiply the coefficient here. This is going to be, the moment the coefficient is, this is a power of 1. We're going to multiply the 1 by b. Well, 1 times b is 1b, and this is now made to x to the 0. X to the 0, of course, is 1, so we can just eliminate it. And of course, we've got a plus c. Well, this is really c to the power of 0 here. Now, if we multiply this by the coefficient, 0 times c is 0c, and x, and we're going to reduce the power by 1. So let's tidy all that up. What do we end up with? Well, this is 2ax, the power of 1, I don't need to put the power of 1, plus 1b times x to the 0. Well, x to the 0 is 1, so it's 1b times 1, which is just b. And we've got a plus. Now, 0 times anything is 0, so this just disappears. So this is all what we've got left. So that is the gradient function. That is really m. But we know that m is 0 at this point here. So let's make it equal to 0. Here it is. So 0 is equal to 2ax plus b. So let's make, well, x the subject, because we want the x value. Here is the x value. So let's go ahead and do that. So let's subtract 2a, or let's subtract b from both sides. Subtract b from that side. Subtract b from that side. So we end up with, and I'm going to rewrite it the other way around, I've got 2ax is equal to negative b. Now let's make x the subject. So I'm going to divide both sides by 2a, divide by 2a, and you can see already where this is heading. So 2a divided by 2a is 1, 1 times x is x, and I'm left with x is equal to negative b on 2a. So the x value is negative b on 2a. Now in this case, what's b? Well, b is 1. It's going to be a negative 1. In this case, it's going to be a negative 1 over 2 times a, and the value for a was in fact 1. 2 times 1, and negative 1 times that is going to equal, I'll write down the bottom because I'm running out of room, is negative 1/2. So the x value is negative 1/2. And now to find the y value, we take this and we plonk that straight back into the equation. We've got y is equal to x squared minus x minus 6. We're going to make x equal to negative 1/2, so it's negative 1/2, all squared, minus negative 1/2 minus 6, and that is equal to negative 6.25. So the coordinate is going to be negative 1/2, comma, negative 6.25. There it is, negative 1/2, comma, negative 6 and I'll put 6.25. So I'm keeping the same format here. And there it is, the turning point there. That there is the turning point. I'll put turning point equals negative 1/2, comma, negative 6.25. And that's how this all kind of plays out. Hopefully that makes sense.